last time we saw each other before school was let out, we've been looking at the relationships between angles within circles and the arcs. And so we're going to continue that. So far we've talked about central angles. And just real quick, I'll go ahead and just do a little bit of drawing over here. So we've talked about central angles, which is where the vertex is on the center of the circle. And in this case, we said the measure of the angle is the same as the measure of the arc. That's the only time the measure of the angle is the same as the measure of the arc. That would be central angles. Then we talked about inscribed angles. And an inscribed angle is when the vertex is on the circle and the sides of the angles are chords. In that case, the measure of the angle is half as big as the measure of the arc. So this is half. And so we're going to continue talking about other ways that you can have angles within circles. Sometimes they're inside, sometimes they're outside the circle. Central angles were inside the circle, or inscribed angles were on the circle. We'll look at some examples of angles inside, outside, and on today. So first we have a tangent and a chord. So this is actually very similar to an inscribed angle in the fact that with both an inscribed angle and these angles where it's a tangent and a chord, you've got the vertex on the circle. Now, this is not considered an inscribed angle because if you remember from last week, as well as what I just quickly reviewed, the vertex is on the circle, but the two sides are not chords. One of the sides is a chord, but one of them is not a chord. So these are not considered inscribed angles, but they do actually have the same properties. So that vertex is on the circle, and they do have the same properties. So this angle here, angle 1, is half as big as this angle here. Okay, that's what this first part says right here. All right, the measure of angle 1 is half as big as the measure of arc AB. All right, then the other part says the measure of angle 2 here is half of arc ABC. So that's this part of the circle over here. All right, so we're going to do a couple examples with those, and then we'll look at another type. All right, so first we're finding the measure of arc DE, which is over here. And I'm going to actually erase that for a second because I just drew over the number we're given. So, sorry about that. So we're given this angle right here. And that angle is 36 degrees. And so that means this arc has to be 36 times 2 because the measure of the arc is, or the angle is half as big as the arc. So there's two ways you could write it. So you could say the angle, which is 36, equals half of the arc DE. So you could go ahead and write it like this, but that's the same thing, saying that taking half of the arc gives you the angle. It also works to say if you double the angle, that will give you the arc. So arc DE. And so that measure of arc DE ends up being 72. All right. And then we're asked to find the measure of angle DEF. So now we're looking here. And that angle, you'll notice that these two angles form a linear pair, so it's going to just be 180 minus 36, and you will get 144. And then the last example for this one is asking the measure of arc DH, so remember that means we're going to go the long way around to E. Okay, and with this one we actually have two options for how we can find it. First option is we know this angle right here, this red angle right here is 144. We just found that. So you could say 144 times 2, which is going to give you 288. The other option you have, and you would find you get the exact same answer, you may notice that blue arc right there and this arc right here just arc DE, which means from D to E, the short route. It creates the whole circle, which is 360. So if you were to take 360 minus that arc right there, which we found very first is 72, 360 minus 72 is 288. So two options for how to find that last arc. You'll notice that either way you still get the same answer. All right, next example. Here we're trying to find the value of A, which is right here. So we're given this angle right here is 8A plus 10. This arc, all the way around there, is 260. So what we know is that this angle is half as big as the arc. Okay, so the angle, which is 8A plus 10, is, and remember back when we were doing, we've done this a couple times in a couple different sections in a various different context, but whenever you make a statement about the relationship and you use the word is, that's where your equal sign is going to go. So I said this angle right here, 8A plus 10 is, so equals half of the arc. So I'm going to take half of 260. So 8A plus 10 equals half of 260, which is 130. Subtract 10. Divide both sides by 8. And A equals 15. Yeah. All right, just had to think about that for a second. All right, so, and again, just a reminder, feel free at any time to pause and try and work it out for yourself before I finish talking. All right, so the next one, we just got done looking at when this angle is on the circle, when the vertex of the angle is on the circle. Next, we're going to look at what happens when the vertex of the angle is inside the circle. Now, I do want to emphasize that this is different than a central angle, because again, a central angle, the vertex is on the center, whereas these are just anywhere within the interior of the circle. So you'll notice that where that green point is, it's not on the center, it's just inside, somewhere on the interior. And so, thinking back to central angles, the measure of the arc and the measure of the angle were the same. Okay. However, if we look at this picture, one thing we know, going way back to chapter 1, is these two red angles right here, angle 1 and angle 1 here, they have to be the same measure because these are vertical angles. And so it wouldn't make sense for this arc and this angle to be the same measure and this arc and this angle to be the same measure, because that would imply that this arc over here and this arc over here are the same measure. And we can definitely see that that's not the case in this picture. And so keep that in mind. Just because this is inside the circle does not mean that it's a central angle. And so the angle and the arc are not going to be the same thing because it's not a central angle. Instead, the measure of this angle is actually going to be the average. So both of these angles are going to be the average of this arc and this arc. So then the question is, how do we find average? We add them up and divide by 2 or multiply by half. Same thing. Okay, and it works the same way with these two angles right here. You'll see it's the exact same formula, just using the 2 arcs that are inside each of those 2 angles. Okay, so these 2 angles are the same. You use the 2 arcs that are inside that pair of vertical angles and find the average of them. All right, so now let's look at a couple of examples of those. So here we have an angle. The angle is inside the circle. Again, it's not a central angle because it's not the vertex on the circle, but the angle is inside the circle. So that means that this angle and this angle are the same, and they're going to be the average of this angle, or sorry, this arc and this arc. So x is going to equal half of 130 plus 156. And so half 130 plus 156 is 286. And half of 286 is 143. All right, so last type of example we're going to look at. We've looked at when the vertex is on the circle, when the vertex is inside the circle. So the last thing we're going to do is look at when the vertex is outside the circle. So there's 3 ways that that could happen, and I've got the 3 examples. In all cases, the angle is outside the circle, and in all cases, the process is the same. So whether you have 2 tangents, a secant and a tangent, or 2 secants. So you'll see that the 3 different options, 2 tangents, 2 secants, or a secant and a tangent, those are the 3 ways that you can form angles outside circles. And all 3 of those ways, the process is going to be the same. So in that case, what you're going to do is you're going to take, so the angle is going to be half of the big arc minus the little arc. So when it was inside the circle, it was plus. Now that it's outside the circle, it's a minus. So it's always going to be the big arc minus the little arc. And I just want to emphasize this bit right now. When I say the big arc and the little arc, I mean within the angle. Okay? So not necessarily the biggest section of the circle overall. This arc over here, this arc over here, this arc over here, those are completely irrelevant in actually finding the angle. Okay? Now, they may be beneficial if we don't know one of the arcs, but in actual setting up the formula, they will not be utilized at all because they're not inside the angle. So they don't directly affect how big that angle is. Okay, so when we say the big arc and the little arc, notice how in all 3 examples it is specifically looking at just the 2 arcs that are inside the angle, that are on the inner part of the angle. Okay, so I just want to emphasize that. All right, so now we're going to look at a couple of different types of examples of these 3 cases.